It's all
in the
Vito's
studio
fault.
audience, all we did was just kind of go over some of the answers. So here's the main point of what you're going to need to learn is this new stuff. Okay, so yeah, I talk,
My bad.
mouth moving, camera on.
Well, because usually you tell me, like, start it.
I know,
true, that
it's Wednesday. Okay,
It's all good.
so here's the beauty of
My
gravity,
bad.
is that there's no new equations to learn. Okay, literally, there are no new equations. The only thing that's going to happen is that instead of talking about just A, we're going to talk about little g, our gravitational acceleration. Literally, everything stays the same. But what is going to be more important, though, is the signs. So generally speaking, when we talk about gravity problems, there's two broad classifications. Where you drop a ball, and then where you throw one. Okay, so we're going to start with relatively simple. So let's say, for example, I happen to have a golf ball. Okay? So I'm going to hold a golf ball up to a height of 2 meters, and I'm just going to drop it. Okay? So we're going to deal with drops first. So here's what's going to be important. Anything going down is going to be defined as being negative values, whether that's acceleration, or whether that's velocity, whether that's displacement. Okay? Generally, what's going to happen is that your point of release can either be defined as 0 and is falling away from that, or you can make the ground the reference point. Typically, what we do is we make the point of release be 0. So, in this situation, I've got this golf ball, and it's 2 meters above the ground, and I'm going to drop it. So, I'm going to make the point that I let go of it be the reference point. So, I'm going to define that as being a 0. Okay? So, knowing that, I want to figure out how long the ball is going to be in the air. I want to figure out how fast it's going when it lands. I want to draw a position time graph, and I want to draw a velocity time graph. Okay? So I've got this ball, height of 2 meters. I'm going to drop it, it's going to fall. Now, there's a couple of things that are hidden within this explanation. Since I drop it, as opposed to throwing it up in the air like that, or throwing it down, if I just drop it, what's my initial velocity going to be? 0. That's going to be huge. Because it's dropped, my initial velocity is going to be 0. So I know that Vy naught is going to equal 0. Okay? Now the reason I put Vy is because I'm talking about vertical motion. Okay? You don't have to put the y in there, but it's not a bad habit to have, because that way eventually we're going to have projectile motion, we're going to have horizontal motion and vertical motion at the same time. Like if I throw this to Vitor and throw it like that, that ball would have horizontal motion and vertical motion at the same time. So this will make sense later on. You'll see the true meaning of this. What happens in the x stays in the x. What happens in the y stays in the y. So anytime you're dealing with vertical motion, that's the only thing that's affected by a gravitational field. Horizontal velocities aren't. So that's why it's a good habit to start to put that Vy there. Now, I want to figure out time. But before we do any equations, let's actually talk about what the position time graph is going to look like. So here's my position time graph. So I'm going to give you 3 options. So we're defining this point up here as being 0. My positions going down like this are going to be negative values. So when it lands, it's going to start at 0, and the final position is going to be at -2. So that's why this is down here at -2. Okay? Later on, you see the mathematical significance of that. So which of these position time graphs is going to match that ball falling from rest and hitting the ground?
The far
Ah.
right one.
This one?
Yes.
Why?
Because the slopes slowly, well, it's becoming more steep because the ball is speeding up as it falls.
Okay. Now, this isn't a math class. I don't want you to think of velocity of like -5 as less than a velocity of -1. Okay, this isn't like a number line thing. Okay, so this is falling faster, line's becoming steeper. What would the middle line look like if I dropped it?
It's constant.
Yeah, it would just fall as a constant velocity, just like this. Okay? Now, the bottom line would be cool. What would the bottom line do?
Speed it.
Yeah, it would fall really fast and then it would slow down right before it hit the ground. Okay? That would be cool, right? We'd have to have jet engines to make that happen. But, so the only thing that we're stuck with is that line. Okay? I know that's going to be the line. Now, let's talk about the velocity time graph. And again, I'm going to give you the exact same shape. There's my velocity time graph. Vanessa, which line? Bottom lip, upper lip, middle lip? Fantastic. You say that with no conviction whatsoever. But your answer is right. Why is it the middle lip? What's the acceleration on Earth caused by gravity?
It's like 9 or 10.
Yeah, close, -9.8. Okay? So, this line, like Vanessa said, my velocity time graph is going to look like this. And that slope of that line is going to be -9.8 meters per second squared. If the Earth was a little bit more massive or a little bit smaller, that actually would have worked out to be -10. Okay, but it's handled out. So, now let's make sure everybody's cool with what I'm talking about at that point of impact. Like when I find that velocity of impact, don't tell me, oh, it's 0 because it hit the ground. Okay? When we're talking about velocity and impact, we're talking how fast it's going right as it hits the ground. Okay? So don't go, oh, it goes to 0 because it hit the ground. No. Okay? This is right at that point of impact. Okay? So let's talk about time. So if you look at what we know, if you look at V, V naught, DAC, we know our acceleration is -9.8 meters per second squared. My initial velocity is 0. My final velocity, that's not a player at this point. Now, I'm going to write something that's wrong, okay? I'll circle back to this, but what I'm going to write at the moment is wrong, okay? I'm just going to put my distance as 2 meters. Later on, you'll see why that's wrong. And you go, why are you doing that, Mr. Burkamp? Because this is what you guys are going to do wrong, and I'm going to show you why it's wrong, okay? And you all sit there and go, Mr. Burkamp, we won't do that. I'm going to tell you that you lie, and then you're going to do that, and then we're all going to giggle. So, and then the time is our unknown value. So, what I want to start with that equation.
No.
No, because it doesn't involve time. So that equation is out, okay? What about that first equation, V equals V naught plus AT?
Yes.
No. We
No, don't want to do that one either. Why?
No final velocity.
I don't know my final velocity, nor do I know my time. Two unknowns, one equation, no good. Leaves us with what?
X equals 1/2 AT squared.
X equals 1/2
AT squared plus V naught T.
plus V naught time. Now, conveniently, because we're dropping the ball, what's my initial velocity?
0.
0. So the beauty of this is that this whole thing goes away, okay? Because I'm dropping the ball. Now, if I throw it up in the air, or if I,
What's the velocity you thought?
is going to make it? Oh, score. Okay.
Just hits the TV.
So, so, for the soccer fans. So, because of the fact that if this thing is gonna be falling, initial velocity is 0, it's gonna hit the ground, right? I'm gonna find this time. V naught drops out. I'm gonna solve this equation for time, okay? So Becca, what does that equation look like solved for time?
It would be 2x divided by a squared.
How about square root?
Yeah.
Okay. Now, this is not a huge equation. It's a very subtle equation. But this is a great equation to have like filed away. So when you're going to deal with objects that are falling or starting from rest, and you're trying to find how, like a time, and you know an acceleration, this is a cool little equation to have filed away. You're going to use this a lot in gravity problems when you start talking about things, how long it takes for something to fall. So make a little note, you might even on your equation sheet make a little note that says, oh, I can solve this for time for dropped objects. Now, what I'm going to do next is wrong, okay? Do not do what I'm about to do. What was this, blue shirt day?
Yes.
Yes.
I didn't get the memo.
I didn't know this.
Okay.
We were all
I didn't read the match every day.
No.
Same thing. Yes.
We gotta coordinate it.
Okay? Why, as that is written, why is that going to be a mathematical train wreck?
Can't have a negative square root.
Yeah, I have a negative underneath the radical. I have a negative underneath the radical. Which means you have to do what? Imaginary time.
Okay.
Okay? Remember that? Okay, math notes, let's hear it, okay? So to only solve this is you end up with imaginary time. Do you think we like imaginary time in physics classes?
No.
Nope. If we like that, we'd be in like English lit. Okay?
Philosophy.
Talking about like, you know, Mad Hatter or something. So here's the deal. So there's a couple of ways we can remedy this. One is that we can just ignore the negative sign. There. Problem solved. Everything's positive underneath the radical. We're all good. Just ignore it. It's all good. Okay? You think that's the best solution?
No.
No.
No. You have to look at these problems holistically. Okay? Go back to that velocity time graph. That velocity time graph has a slope of negative 9.8 meters per second squared. My position time graph ends up at negative 2. Okay? So if you have that displacement as positive 2, that doesn't match with your position time graph. Your position time graph ends up at negative 2. And here's the other thing. If you go to your velocity time graph and you're going to find that area, what's the sign of that area on that velocity time graph? I don't worry about the number. What's the
Negative.
It's going to be a negative value. And because we know how far it falls, we know that area is going to be negative 2 meters. So this is where it all goes full circle. If you're willing to come in here and go, wow, that's actually negative 2 meters, okay, now it's all good. Because now I have two negatives underneath the radical. That becomes a positive. Now I don't have to worry about imaginary time. So that's why I said, if you work this holistically and you make everything kind of fit in this big picture, it all makes sense. Where you run into trouble is you go, oh man, I got a negative underneath the radical. Bergkamp will never know. I'll just ignore it. And you're right. I will not know. If you write 2 divided by negative 9.8, I'll probably look at it and I'll snarkily write, hey, imaginary time, cool, okay? On the test, I will look at this. On the test, I promise you, I'm going to go through calculations like this, and if you have 2 divided by negative 9.8, I will snarkily write, ooh, cool, imaginary time. And you will not get full credit. And then you go, Mr. Bergkamp, I got the right time. I said, I don't care. Your process is fundamentally flawed. You don't understand physics. So I'm not doing that to be a jerk. I'm doing that to make sure that you actually understand how this works. Now, here's what you're gonna do wrong. You're gonna get so wrapped up in going, oh, I remember the negative sign. You're gonna take 4 and you're gonna divide it by 9.8 and you're gonna forget to take the square root. I swear to God, that's what you're gonna do wrong. And again, you sit there and go, it's gonna happen, okay? Cooper, you're the first one going, oh, Mr. Kepler, I would do that. You lie. So, somebody take 4 and divide that by 9.8. And then take the square root of it. 3 significant digits. Should be less than 1.
0.638.
0.638?
639.
Oh.
639.
0.639?
Yeah.
Everybody cool with that? Okay. Now, so let's see if that matches. So 1 Mississippi is like 1 second, right? So I'm going to hold this up and drop it. 1, 2, 3, 1 missa, okay? So I got to about 1 missa. So 1 missa is about 0.639 seconds, okay? If you round up, okay? So that kind of matches. Now, if I got all the way to 1 Mississippi, either gravity has changed or our mathematical description of the universe is jacked up, okay? But since we hit 1 missa when it hit, that's 0.639, yeah, we're good, okay? Now, let's talk about how fast it's going when it hits the ground. There's 2 different ways that you can do this. One option is that you can go, this is an option. I'm not saying it's the best option. I'm saying it's an option. You could use V equals V naught plus AT. Okay, you can use this equation. Okay, you can do this. What's your initial velocity?
0.
0. Do you know your acceleration?
Yes.
Negative 9.8 meters per second squared. Do you know your time?
Now you
0.639 seconds. This is a slope intercept. Okay, that's all this is that we're saying we're going to start up here at 0. We know our time is 0.639 seconds. We know our acceleration. We're just trying to find the y value that corresponds with an x value of 0.639 seconds. That's it. It's an x and y coordinate system. Okay, we're just finding the y coordinate that matches with an x coordinate of 1 missile. Okay, all we got. Now, when you do this, put away that stopwatch. That's annoying.
Come on, Lisa.
You don't talk. You have it too. So somebody take 0.639 times negative 9.8. You're gonna get 6 something.
Like negative 6.
What'd you get?
Negative 6.262.
So negative 26 meters per second. Okay? Now, let's look at the big picture. Does it make sense that that velocity was less than negative 9.8 meters per second?
Yes.
Why?
Because you're not traveling for a full second, so it won't get up to negative 9.8.
Winner, chicken dinner. You have to understand what acceleration is, okay? Acceleration is your rate of change in your velocity. So if that ball fell for an entire second, okay? If it fell for an entire second, how fast would it be going at the point of impact? Negative 9.8 meters per second, right? Since our time was less than a second, my velocity has to be less than negative 9.8. So that's a handy thing to look at, okay? Don't get so wrapped up in the equations and plugging numbers into a calculator and having the oracle speak to you that you don't step back and look and go, hey, does this make sense? You know? So, that's one way to find that velocity, okay? Is to do this. But what's the disadvantage of finding the final velocity that way?
You're using derived value.
I'm using that derived value of time. If I screwed up the time, I screwed up that velocity, okay? Now, the advantage of this, and this is what you see compared to the other method, the advantage of this is that it automatically generates your negative velocity because you're using the slope of the line. That's the advantage of it. So you automatically get a negative velocity. Now, is there a way to find the velocity without using time?
Is that equation?
Ah! Let's talk about that equation. Let's talk about that. Literally, let's talk about that. So if we try and use that equation, and we go v squared equals v naught squared plus 2ad. What's my initial velocity?
0.
Do I know my acceleration?
Yes.
Do I know my distance?
Yes.
Now, I'm going to do this wrong. Okay? Do not do what I'm about to do. V naught, that's 0. That isn't the part that's wrong, by the way. So I got 2 times 9.8 meters per second squared. I know that's negative, times 2 meters. Pop, you shake your head no. Why?
Because you're going to have negative under the...
I'm going to have negative underneath the radical. Okay? I'm going to have imaginary velocity, which is, don't try and use that excuse if you ever get pulled over. The cop says, you know how fast you're going? I have an imaginary velocity. You want to guess with me on that one? Bad things are going to happen. Okay? I'm going to tell you that right. My physics teacher said that would be funny. No. I will go to court and completely testify against you. Okay? And I told the judge, I said, do not invoke imaginary velocity if you're pulled over. But what can we do to fix the situation?
Negative 2 meters.
Now, if I do that, now we're cool.
Yeah.
Because now we have positive numbers underneath the radical. Okay? And again, the sooner you embrace this idea of a holistic problem, the better off you're going to be. Now, somebody take basically 4 times 9.8 and then take the square root of that. And tell me what the oracle says the answer is.
6.260.
Okay? So the oracle says the answer is 6.26.
Fight. We've got to fight. 6.26 meters per second. So why is that technically wrong?
Because it should be negative.
Well, what's the square root of 4?
2.
2, negative 2.
Or,
Negative
Negative
2.
2.
guess what?
Plus.
Pick the negative root.
Yep.
Problem solved. Okay? So the advantage of this method is that you're using derived value, you're using known values. The disadvantage is that you have to remember to choose the negative root. Okay? The advantage of using v equals v naught plus at is that you don't have to remember to choose the negative value. It automatically generates a negative velocity. The disadvantage is that if you screwed up the time, you screwed up that final velocity. So that's the roll of the dice that you have to take. It's like, if you're feeling solid about that time, roll the dice. Now, if you really want to be confident, do both, okay, and see if they match up. Because I can't have one set of kinematic equations saying, oh, it's going 6.26 meters per second, and another set of equations going, no, it's going 5.2. No, bad, okay? They both have to produce that same velocity. One you use that equation, the other you use the time function, okay? All right, so stop that for a second. Stand up, take a stretch. That's a bit much. Okay, so here's the next type of problem that you can do. So on this one, I'm going to take this ball, I'm going to throw it up in the air, okay? So this one is going to go up. Oddly enough, it's going to come back down.
Is that going?
So I'm going to throw a ball up in the air, Vitor, pick a number between 15 and 25.
20.
Okay. So I'm going to have an initial velocity of 20 meters per second. Okay? So that's how fast I'm going to throw the ball when it goes up in the air, 20 meters per second. So I want to find what my position time graph is gonna look like, what my velocity time graph is gonna look like. I wanna find the time up. I wanna find the time down. I wanna find the maximum height. I wanna find out how high it is 1 second into the flight. I want to figure out how fast it's going at 1 second into the flight. And then I want to find out how high it is at 2.2 seconds into the flight and the velocity at 2.2 seconds into the flight.
What?
So I'm going to do all of that with one number. Okay? I'm going to do all of that, I know, one number.
Well,
You know more.
yeah, you know more.
I do know. What else do I know?
Gravity.
Oh, I know gravity, right? Gravity does what?
It gives you
Accelerates it.
Causes an acceleration. So what's the acceleration caused by gravity?
9.
Negative
Negative
9.8.
Now technically, that's negative 9.80 meters per second squared, so that's how, why we can always have like 3 significant digits. Now, among the list of things that annoy me, don't say, oh, gravity is negative 9.8. Oh, that's just so wrong, okay? It's just so wrong. You can say gravity causes an acceleration of negative 9.8 meters per second squared. But just don't see, oh, gravity is negative 9.8. Stop, okay? It just doesn't make any sense. All right, now here's what's also going to be important. I'm going to throw that ball up in the air. When that ball reaches its maximum height, what's the final velocity going to be?
0.
Oh, winner, chicken dinner. We can take advantage of that action. So we know when that thing is at the top, it's going to have a velocity of
0
meters per second, okay? So on the way up, it's going to go to 0. On the way down, what's the initial velocity going to be?
0.
0.
That's going to be a key thing. So what we can do is basically break this up into 2 different flights, okay? On the way up, on the way down, okay? Cool with that? Okay,
and you could use that.
so let's start with my position time graph. So what's the position time graph going to look like? Connor, what's my position time graph going to look like?
It should be like that, or
Mm-hmm.
yeah.
Like that?
Yeah.
Parabola.
It's parabola
So as opposed to this, it's going to look like that.
because it's not speeding up on the way up; it's slowing down on the way up.
So something like that?
That would be the full graph. Correct?
Yeah. So for the whole
Yeah.
position
Which
time
is for
graph,
further pro
right?
hours is that too.
The whole position time graph would be that parabolic curve,
Yes.
okay? Now, at time 0, if you were to come in here and draw a tangent line at time 0, what would the slope of that tangent line be?
20 meters per second.
20 meters per second, because that's how fast you're going at the beginning. So as soon as it leaves my hand, what does it start to do?
Slow down.
Slow down. Guess what? What's that graph going to do?
Slow down.
It's going to become more
Flat.
horizontal, okay? Where are you at that point?
0 meters per
Your
second.
velocity is
0 meters per
0
second.
because you are at your
Max height.
maximum height. After that, what happens to your velocity?
Increases.
It becomes negative and it gets
Bigger.
bigger, right? Okay. So we got that one. That's cool. What about my velocity time graph? Where is it going to start at?
Up at 20.
20 meters.
It's going to start up at
20 meters per second.
20 meters per second. And then what's it going to do?
Just slope down gradually.
Gradually?
At negative 9.8 meters per second.
So a straight sloping line.
Yes.
Yeah.
Some action like that.
It's not very straight.
Pretty good.
Back off me.
The iPad was nice because it like actually.
I know
made
it
your
would
last
automatically
straight.
fill that in.
Yeah.
Yeah, don't think I don't miss that up. So now, if I were to find that area, what would that represent?
This
Distance.
Otherwise known as the,
place. Oh,
We're all seeing different
Okay.
answers.
how about the maximum height?
Oh yeah, that's
Right?
it.
That would tell you the maximum height of the ball.
okay.
True?
True.
Okay. Now, let's talk about the time up. is my time up gonna be bigger or smaller than 1 second?
Bigger,
Why?
because it just takes a while. I don't know. No, because the negative 9.8 meters per second is the acceleration, and that's smaller than 20
Good
meters per second.
explanation.
It just takes
Crazy. That's crazy. I didn't even think about that.
Okay.
We don't got Superman stopping trains out here.
I know, hey, you know, okay, so. But what's funny is that I knew what you meant. Okay, so let's put this, it's gonna take a while, into a mathematical justification.
Yeah.
What if, okay, what if my initial velocity was exactly 9.8 meters per second? I throw this thing up with an initial velocity of exactly 9.8 meters per second.
It would take 1 second.
It would take exactly 1 second to go to 0, right? Because that's what that slope means. So since my velocity is bigger than 9.8,
It's gonna take more.
my time has to be
Greater
More
than
than
1 second.
greater than 1 second. Now, some people like an analogy of money, okay? So let's say let's approximate our gravitational acceleration to be 10, okay? So you show up at the mall with a certain amount of money. And the rule is you have to spend, this is what makes America America, you have to spend $10 per second that you're at the mall, okay? So for every second that goes by, your money drops 10 bucks. So you show up with 20 bucks. How long is it going to take you to run out of money?
2 seconds.
About 2 seconds, right? So my velocity is 20 meters per second. If the acceleration due to gravity is negative 10, it's going to take me about 2 seconds, okay? It's a ballpark, right? So that means this thing should take about 2 seconds to go up. Ballpark, but at least it gives me an estimate, okay? All right, so let's tackle time up. So how do you want to tackle time up? What do you want to do?
You can take
Time up.
Time up.
take the velocity minus the velocity naught over.
Start with that, v equals v naught plus at,
Yeah,
Yeah.
and solve for,
No.
time.
No.
Why wouldn't you use that one? That was a way better.
Because our initial velocity isn't 0, so it's gonna be harder to do that one. I guess no, it's easy, but
that's the only way to do this.
oh, it is.
Yeah.
Okay.
Or the simplest way, how about that? So if you go v minus v naught over,
Time. Yeah, acceleration.
right? Now, this is why you have to watch the sequence. So this has to be 0 minus 20 meters per second divided by negative 9.8 meters per second squared, okay? You have to do it in this sequence. Now, and I've seen this happen countless times. Let's say you screw this up and you forget this and you make this positive, and I see this happen all the time. Kids that go 0 minus 20, they'll punch that into your calculator because they don't trust themselves to do this, okay? They will punch in 0 minus 20. And then they'll divide by positive 9.8, and they'll get a negative time. And they'll write down negative time, and at that point they'll realize, like, huh, this is a little bit problematic. We have negative time. And what they'll do is they'll erase the negative sign. They won't fix it, okay? They won't realize what's wrong. They'll just erase the negative sign. That's like you're driving your car and you hear a weird noise in your engine and you don't know what's wrong with it. Oh, I'll just turn up the radio. Problem fixed. Okay? Is your engine still knocking? No, that's good, man. I got some serious beats going on, but my engine is fine. Okay? So if you get negative time, you did something wrong. Okay? Just don't ignore it. No, it'll go away. It's all good. No, you have done something wrong. So somebody take 20 and divide that by 9.8.
2 point,
About 2.
2.0.
About 2.
2.0 something.
Because it's going to take a while. So
2.04, is that it?
2.04,
Yeah.
okay? 2.04 is a technical version of OY, okay?
Valid.
Okay? That's like 1 missa is, okay. So now we have our own time scale in this room. What's a while? 2.04 seconds. 1 Mississippi, 0.639 all day long. Okay.
Just miss it.
Yeah, I'm going to put
Half
that
the
as one of the
state, half the state.
multiple choice answers. 1 missa.
What is half of Mississippi?
Okay. So what's the square root of Mississippi squared? Missa. Okay. Now,
Wait.
so at this point, if we go to our velocity time graph, so we started at 20 meters per second. At this point, we're at 2.04 seconds. Now, could I, if I wanted to, could I use that velocity time graph to find my maximum height?
Yes.
What would I do?
Find the
Find
area.
the area.
Find the area underneath this triangle,
We.
right? Go, ooh, I'm the president of the area club. This is in my wheelhouse, okay? Now, if you like this, you can do this. You can go, oh, area equals 1/2 base times height.
Making an area.
So I got 1/2 times 2.04 seconds
Just have toast.
times 20 meters per second, and you're gonna get 20.4 meters. It's cool. What's the disadvantage?
Oh, you're using derived.
I'm using my time. If my time is wrong, that's wrong. So is there a way to find that maximum height without using time?
That.
That equation.
That's what I would recommend. So the other way to find the maximum height is to use that equation of v squared equals v naught squared plus 280.
280.
So I got v squared minus
V naught squared.
over,
2A.
2A.
so now I have, now what's my final velocity?
0.
So I have 0 squared minus
20.
meters per second squared. Do not forget to square that, okay? Now, I'm going to do this wrong. I'm just going to put 9.8 meters per second squared underneath it. Why is this going to be so problematic?
It's going to be a
Do
negative.
negative.
I'm going to have a negative displacement. It's like, okay, cool. I'm going to throw the ball up in the air like this, and I'm going to have negative displacement. That's problematic, okay? But again,
Upside down.
if you, or just flip it over. If you work this holistically and you go, Mr. Burkamp, that's a negative 9.8, now what's gonna happen?
Positive.
Now you're gonna get a positive displacement, okay?
Yes.
So this is a little bit more difficult
Solar.
mathematically, just because you have to square things, but you're not going off derived values. Okay, so here's what we found so far. Our time up was 2.04 seconds. What do you think our time down is going to be?
About the same.
About a while.
About a while. How about the same, about a while? Now, you can do this, and this is a huge if. You can do this if the flight is symmetrical. So if it returns back to that same point, you can assume that the time up is the same as the time down. And that's a huge if it's symmetrical. Now, if I throw it up in the air and it falls all the way down to the ground, guess what? My time up is going to be less than my time down. Okay? So you can assume flights are symmetrical, but that's a huge, huge, huge assumption. That the time up is the same as time down, but that's only if it returns back to that same point. Okay, so we found our maximum height, and that was 20.4 meters. That's cool, okay?
Oh, 5.
Now I need to find a couple of things. I need to figure out the height and the velocity at 1 second into this thing. Now, there is one way, and only one way, to figure out the height at 1 second. The only way you can do that is to do that distance equals 1/2 AT squared plus V naught time. For those of you that are math nerds, which is most of you, if not all of you, that's it. This is technically a function equation.
Yeah.
What this does is that it gives you height as a function of time, okay? So this is technically like a function of x. If you really want to get fancy, we put an F out in front of this thing. Because we know what our acceleration is, negative 9.8 meters per second squared. We know our initial velocity is
0. No, 20.
20.
I thought we were talking about that.
And then we know our times, right? So this allows us to find height at any point in this flight, okay? Now, if you came in here and you said, okay, hey, this is going to be 1/2, negative 9.8 meters per second squared, times some time squared plus 20 meters per second times some value of time. Now, if you plugged in the flight time to reach that maximum height, this is the other way that you can find the maximum height. There's actually a third way. You can find the area, you can use that equation, or you could use this function equation and you plug in the time it takes to reach its maximum height.
So
That's the third way that you can do it.
you just can't go wrong if you use one of the equations.
Oh yeah, oh believe me. Oh, any of these can go wrong, okay? You talk to someone that's taught for over 30 years. I've seen everything that could possibly go
Do all
wrong.
three and make
Okay.
sure they're the same.
Lou's gonna
Plug
find
them all
new ways
in.
for you.
Okay. Okay. Now, so here's the deal. If we specifically want to find at 1 second, you're going to come in here and you're going to put in 1 second and 1 second. Now, here's what you're going to do wrong. You're going to do two things wrong with this. You're going to forget to square this time, or you're going to forget to make this a negative value. Okay, so if you're going to use this function equation, this has to be a negative value. Okay, listen to me. This has to be a negative value because it's a function equation. So basically, you're going to have 20 plus negative 4.9, which should get you 15.1,
Yes. No. Yeah.
I think. Now, does that answer make sense? What's your maximum height?
No, that does not make sense.
20.4, right? And that occurs at 2 seconds. So at 1 second, my pipe has to be less than,
20.
yeah. If I did this and I got an answer of like 35, it's like, oh, that's kind of weird. My maximum height is 20 meters. How high is it at 1 second? 35 meters. Huh, really? Let's think that through.
Going down.
Even in Colorado, you can't be that high that fast. Okay? So, to figure out how fast you're going at 1 second. The only way you can do that is V equals V naught plus AT. And don't look at that and go, oh, it's physics, it's an equation. It's a slope intercept, okay? How fast are you going initially?
20 meters.
20, that's your y-intercept. 1 second later, how much has your velocity changed?
9.8.
9.8. Take 20 minus 9.8. Okay? Don't get so wrapped up in the equations that you lose track of what is physically taking place. So now, if you are in math there, again, shout out for that. So that's going to be negative 9.8 meters per second squared times
The change in
1 second. Guess what? You're going to get
10.2
10.2 meters per
second.
second.
But that's different.
Huh?
I'm sorry, wait, why are they different?
What do you mean?
The 10.2 and the 15.2?
That's your height. The
Oh, meters,
15.1
okay,
is
yeah.
how high you are. That's how fast you're going.
Oh, meters, okay. That makes sense.
Now, this is where this all comes together. If you go back to that parabolic curve, at 1 second, you're at 15.1 meters. True?
Yes.
Because that's that height. If you were to draw that tangent line, what would the slope of that tangent line be?
10.2.
10.2 meters per second. Okay? If you go to 2.04 seconds, what's the slope of that tangent line going to be?
0.
0. Because that's when you are at. So if you plug in 2 seconds in here, or 2.04 seconds, you're going to get a velocity of 0. Okay? So with this one, when you go, if I could pick any time,
Let's get out. Come on. Get out.
I thought I